Uh, Hello all. So today in this series, means in this continuation, we are starting one new series that is interview preparation. Okay, so one more series is going on in parallel. In that, we are doing live coding. Like I will upload videos in that also, and then in parallel, I am starting this interview preparation series. And after some time, I will start this one more series also that is on Google Cloud platform. Okay, so for MLOps part, I will start this series also. So skip this part. For today, we will start with our first video in interview preparation. So in this series, what we will do, we will cover all the questions uh, which may be asked in question in interview. Okay, and I will provide the link of all the all the resources which I will use here. Like today, we will discuss model evaluation techniques. Okay, so for model evaluation techniques, this is the resource I will use to explain you. So I will provide that also. Okay. Okay. So Uh, I will ask questions one by one, then I will explain them. Okay. So let's start with the first question. Interviewer may ask you, what does model evaluation techniques determine? Means interview want to know why we use a model evaluation techniques. Okay. So if we are developing any model like classification model or regression model, so we need to find out that how our model is performing. Okay, so to find how our model is performing, we use some techniques. So those techniques are known as model evaluation techniques. So if I will say in like precise answer, that will be model evaluation techniques are used to determine how our model is performing. Okay, so this will be the answer of question one. Like here you can see how well the model perform on unseen data or future data. Okay, and like whether the model is overfitting, underfitting, or generalizing well. All these are the different ways to write the same thing, but the only thing is they are used to determine how our model is performing. Now come the next question. Means it is like interviewer will not ask in general like tell me any five model evaluation techniques, but he may ask tell me about some model evaluation techniques for regression problem, and then he may ask and tell me model evaluation techniques for classification problems. So we use a different techniques for regression and different techniques for classification. So if I will talk about a model evaluation techniques for regression problems, these can be mean absolute error or mean squared error, then root mean squared error. You have heard a lot about it. Then R squared. Okay, and in the last we have adjusted R squared. So we will discuss them in detail. So this is the mean absolute error, then mean squared error, root mean squared error, R squared, and adjusted R squared. And then inside the part, it is asking about the model evaluation techniques for classification problems. So for a classification problem, we may say that first is accuracy. Then we may use recall. For recall, we use like true positive rate is the another name for recall. Okay, and accuracy, recall, and then we have precision. Then we may use confusion matrix. You have heard or not heard a name, confusion matrix. Then we have F, F beta score. Okay, I will explain why we use F beta score, and uh, all of these I will explain. Okay, and then we have classification report. We generate classification report. We have specificity. Okay, and then we have false positive rate, and also last and most important is AUC ROC curve. So AUC ROC is area. It stands for area under the curve and receiver operating characteristics. So eight model evaluation techniques will be accuracy, then confusion matrix, then we have precision and recall, uh, uh, then F beta score. So if we provide beta value as 1, then it become F1 score. Then we have a ROC AUC curve, and then we have a classification report. So these all we will discuss in detail. Okay. Uh, Now let's discuss about them one by one. Okay. So first of all, what is mean absolute error? So it is the average of it is the average of absolute difference between actual values and predicted values. So what is error actually basically? So error is y actual minus y predicted. Okay. So what is the actual value of our target variable minus what is our prediction? So that difference is called error. So that difference is called error. Okay. So what will mean absolute error? It is the average of absolute difference. Absolute means we don't consider sign. We take mod of it. So we all only consider quantity. Okay. So this is the mean absolute error. Then come the mean squared error. So what is mean squared error? It is the average of squared of difference between actual value and predicted value. If we take the square of this difference, okay, and do the average, then this is called mean squared error. Okay, so this is the mean squared error. Then come root mean squared error, RMSE. It is the square root of the mean of the square error. So if we take the square root of this mean square error, that will become root mean square error. So if we already have mean squared error, then what is the need of RMSE? Okay, this is the question which may ask in the interview. So see guys, here we are doing actual minus predicted. For example, this is the like price of any car. Okay, we are developing model means a model for predicting the price of a car. So what YA and YB both are the price, and if we take the square of their difference, so that will become price square like rupees square. So rupees square does not make any sense. That's why we take square root. Okay, so it it will make sense. So that's why we use RMSE, and it is generally most used technique for regression problem. Then come the R squared. R squared is the what is R squared? It is the proportion of variance explained by the model. What do you mean by proportion of variance explained by the model? Uh, for example, suppose you have explanatory variable x, then y actual, and then y predicted. Okay, and in the last we have error. That is the difference between y actual minus y predicted. Okay, so what is R squared? It is the measure of variance explained by the model. For example, this is the total variance, means house price you may consider this is the house price and this is the total variance. And by our model is able to explain some of the variance, means up to certain extent we are able to identify the price, but still there will be some error. That error is like unexplained variance. Okay, so that is called R squared error. Its formula is 1 minus 1 minus unexplained variance upon total variance, or you can say explained variance upon total variance. Okay, so this is the thing. Now come the adjusted R square. Oh, so what is adjusted R square? It measure the variance explained by only those explanatory variables which are actually contributing to the model. Because it has one minus, like something is there, and in the denominator it has n minus p minus 1. So n is the uh, here. So what happened? Like when just a second. So what happened? 1 minus n is like a number of observations, and p is the explanatory variables. So when these explanatory variables increase, so what happen? This denominator value uh, has decreased. Okay, so if this denominator decrease, so this division value has increased. So 1 minus this will become lower. Okay, so like there is some manipulation in formula. That's why we call it adjusted R squared. In the core, what we can say, it me it measure proportion of variance explained by only those independent variables that really help in explaining the dependent variable. Okay, so that is adjusted R squared. Okay, so this is all about regression. Okay, so uh, okay, so you can see that these are the formulas: y actual minus y predicted by n summation. Okay, then summation of y actual minus y predicted ka square, and RMS is y actual minus y predicted ka square by n, and then under root. Then R squared is 1 minus ka sum square, means residual and SS total. And this is the formula for adjusted R square. So you can go through it. N is the number of observations and P is the total number of independent variables. Adjusted R square penalizes unnecessary features. and is better for comparing model with different feature counts. Okay, so if you have two models which have different feature counts, then we can compare them using adjusted R square. Okay, now come this classification uh, for classification. Okay, so what is accuracy? So accuracy, it is the ratio of uh, correct predictions to the total number of predictions. So in a classification, there is slightly difference. Okay, because here we don't have uh, continuous values, so that's why here method is slightly different. So first is accuracy. It is the uh, it is a ratio of number of correct predictions to the total number of predictions. So number of correct predictions upon total number of predictions. So that we called accuracy. Okay, so what happen if we have imbalanced data? For example, we can consider cancer data set. Means 100 patients are coming to us. Okay, and for those 100 patients, suppose one patient found positive, means one patient have cancer, and 99 patients won't have cancer. Okay, so in that case, uh, for example, we have created one model which is a very naive, means very easy model, and what that model do, it just say that patient does not have cancer. So, for example, even if positive patient will come, model will tell that it does not have cancer. Okay, so like this data is imbalanced. Imbalanced data means one class have a significantly higher number of samples compared to another class. So that is called imbalanced data. So in case of imbalanced data, accuracy doesn't work very well. Okay. For example, as I was telling that we have very naive model which is telling that uh, no one have cancer. So if we deploy that model, so if you check our accuracy, okay, so what number of correct predictions will be 99. It is doing only one incorrect prediction that for that one patient, and then uh, total predictions 100. So you can see that this model is having 99% accuracy. Okay, so this model have 99% accuracy, but it is like very what you say a very dangerous model means for everyone it has very great accuracy, but it is not a good choice means because data is imbalanced. So that's why we jump forward for different techniques. Okay, uh, now come the confusion matrix. Okay. So what happen in confusion matrix? In confusion matrix, we create one matrix. Here we have actual values, and here we have uh, a predicted value. Okay. Here we have actual 0 and actual 1. Here we have predicted 0 and predicted 1. Okay. And also we can say that this is negative and this is positive. Negative for 0 and positive for 1. Okay, so for example, we find the number we value is negative. Okay, so if a value is negative and we predict it as negative, so this will become true negative. Okay, then actual value is negative, but we predicted as positive, so it will become false positive. Okay, and here you see actual value is positive, but we are predicting as negative. So this cell will contain false negative, and here we have true positive. Means actual value is positive, and we are also predicting it as positive. So this representation is we called confusion matrix. Okay, this is what we call confusion matrix, and here we have type 1 and type 2 error. This false positive is known as type 1 error, and this false negative is known as type 2 error. Okay, okay. So now this is the confusion matrix. Uh, so if we want to describe as the confusion matrix, so it describes the performance summary of prediction result of a classification matrix. So that will be the uh, definition of confusion matrix. Just a second, guys. Just a minute. Okay. So this is called confusion matrix. Okay. So it gives performance summary of prediction result of a classification model. Now come the precision. Sorry, before precision we go to recall. So what is a recall? It is the number of it is a ratio like it is a ratio of correct positive predictions. It is the ratio of correct positive predictions to the actual number of positive in the sample. Okay, so recall is correct positive true positive, that is correct positive prediction to the total number of positive total number of actual positive. So that will be true positive plus false negative. Because we know that what is false negative means these values are in actual these values are positive, but by mistake we consider predict them as negative. So recall is the ratio of correct positive predictions to the total number of actual positive. So this is the recall. Uh, recall is means that if we have total 100 actual default, how many of them was I able to catch? Then comes the precision. Precision is the ratio of correct positive predictions to the total number of positive predictions. So, what is precision? It is the correct positive predictions to the total number of positive predictions. True positive plus false positive, total positive predictions. Okay, so this is what we call uh, precision. Okay, so this is precision. Now means this precision generally measure how precise our classifier is when predicting positive instances. So this is precision. Uh, Now, when we should minimize precision and when we should minimize recall. Okay. So if we want to minimize false negative values, okay. If we want to minimize false negative value, in that case, we need to maximize recall. Okay. So like if there is the case like we discuss cancer patient. So if our model is predicting any patient as a not a cancer patient, which in actual have cancer. So that is more dangerous. Okay. So, and if we consider them by mistake as positive, that may cost some additional bill, but life will be saved. But if we consider it as false negative, then life of the patient is in danger, which is more important for us. Okay, so if we want to minimize false negative, then we maximize recall, and if we want to minimize false positive, in that case we maximize precision. Okay, false positive. What is the scenario for false positive? Uh, like we want to distribute laptops to we have some laptops and we want to distribute to students who need them. So if we are means if we are giving considering any rich child as poor, so that will cost us a lot. So in that case we may need to reduce false positive. Okay, so that is the thing. Now now come the F beta score. Okay, uh, there may be chances means both precision and recall are we need to balance. So what is the F beta score? F beta score is the weighted harmonic mean of recall and precision. Okay, so like F beta score give weightage to recall by beta square. Okay, so if we want to give importance to recall, we increase the beta value, and if both are equally important, then we provide beta value as 1. So F1 that we call F1 score. So F1 will be 2 into precision into recall upon precision plus recall. This is F1 score. Okay. And in F beta, if like uh, I will discuss in some time. If we consider F0 means we are not giving any importance to recall. In that case, value of F0 will be precision. Okay, and if we give very high means very high importance to uh, a recall and keep it as F infinite. Then then we have value as recall for every type school. Okay, that is the case. Now come the ROC AUC curve. Uh, okay, before jumping to ROC AUC curve, two more things are there, like specificity. Okay, uh, one is specificity and another is false positive rate. Okay, false positive rate. We discuss about these two also. Then we can understand ROC curve better. So, what is specificity? Uh, Specificity relates to the classifier ability to identify negative result. Okay, so like it is true negative and actual negative. So it will be uh, true negative plus false positive. So what is specificity? It is the specificity related to the classifier ability to identify negative results. Means uh, true negative upon total actual negative. So that is specificity. And what is false positive rate? For it is the proportion of negative data points that are mistakenly considered as positive to all negative data points. Okay, so like it is like some data points are there and we mistakenly considered as false positive upon total negative data points. So this is what we call false positive rate. So this is the thing. Okay, so now come our most important part, that is ROC AUC curve. So what is the full form of ROC AUC? It is receiver operating characteristics area under the curve. Okay, that is ROC AUC curve. Now, what is the definition of ROC AUC curve? ROC AUC curve is a performance measurement for classification problems at various threshold uh, settings. Okay, I will explain you what it means. But for now, what is ROC AUC curve? It is the performance measurement for a classification problem at various threshold settings. Also, it is the curve, ROC curve is the curve between false positive rate and true positive rate. Okay, it is the curve between false positive rate and true positive rate. So, like this, our curve generally happen. Okay, so this is the AUC ROC curve. Okay, so like I will explain you after some time. And this is the class. This part I will explain you in figure. Okay, and the last is the classification report. Classification report function build a text report showing main classification metrics. Okay, like precision, recall, and F1 score. Also, it shows the support for those values, means from how many values, means how many rows we are considering. Okay, so that is the thing. Let's clear this and then go to the figures to explain them in details. Okay, so let's jump to our questions. So most of the questions I have answered, I think already. Okay, so name any five models. I have answered. Name any eight model evaluation techniques. We have answered. Then we have defined mean absolute error, mean squared error, RMSE, R squared, and adjusted R squared. Okay. Also, we have seen their formulas. Now we see what is accuracy and its formula. Then we see uh, what does a confusion matrix describe. Okay. Also name two types of errors. So we mentioned like type 1 error and type 2 error. Also I showed you by drawing a diagram. On y-axis we have actual values, on index we have actual values, on columns we have predicted value. So 0 1 negative positive, like this. Now then we discuss what is a recall, and we say that its other two names are recall and true positive rate, and like uh, the name for a recall basically is sensitivity. Okay, we can call it sensitivity, recall, or true positive rate, and we discuss it. Then we see what is precision, and we see formula and explain what it means. Then we discuss when what should be minimized when we want to minimize false negative. So we say that if we want to minimize false negative, we need to maximize recall. And when we want to minimize false positive, we need to maximize precision. Okay. Then we check what is F beta score. It is the weighted harmonic mean of recall and precision, and we see its formula also, and its range is generally between 0 to 1. Then we see the formula of F1 score and explain what does it mean. It gives equal importance to recall and precision. Also, we see the value of F0 will be like we are not giving any importance to recall, so F0 will be equal to precision. And F infinite, we are giving all the importance to recall, so F infinite will be R, that is recall. Now, question number 11, what does specificity mean? So, it is the model's ability to like it is the model ability to uh, I- identify negative uh, result. So, true negative upon total actual negative. And then we have one more also, which is not mentioned here, true positive rate. It is the proportion of negative points that are mistakenly considered as positive, that is false positive rate. Okay, and then we have ROC AUC curve. So first question was interviewer may ask what is the full form of AUC ROC. So ROC curve is a curve, sorry, AUC ROC is area under the curve, receiver operating characteristics. Uh, and then ROC curve is the curve between false positive rate and true positive rate. Okay. Then uh, next question is AUC ROC curve is the performance measurement for, and also draw two diagrams. One diagram I have drawn. Second I will show you in the uh, like PDF. Okay. So AUC ROC is the performance measurement for the classification problem at various threshold settings. Okay. So that is the thing. So let's discuss this AUC ROC also. Then we will conclude this video. Just a second. Okay. So jump. Let's jump here. So this part we have seen R squared adjusted R squared we have seen accuracy is the correct predictions to the total number of predictions. So true positive plus true negative upon true positive, true negative, false positive and false negative. Okay, so a balanced data set classes are nearly equal. So accuracy can be useful. For imbalanced data set, one class dominates. I told you. So accuracy can be misleading. Okay, so in that case, we will not use accuracy. For example, fraud detection transactions. Okay, so there are very less transactions which will be fraudulent. So in that case, we cannot use accuracy for measuring that model. Then comes the confusion matrix. So it is actual and it is predictive. This is negative, so 0 and positive for 1. And here negative 0, positive 1. So this is true negative, it is false positive. It is false negative and it is true positive. So confusion matrix describe the performance summary of a classification model by comparing actual classes against predicted classes. Okay, so we have type 1 error that is called false positive, and type 2 error is false negative. And we need to check what we need to minimize on the basis of business cost is what is more important for our business. I told you that also. Then come recall and precision. Recall have other names like sensitivity and true positive rate. And this is the formula for recall. And this is for precision. Then come business cost of errors. When to minimize false negative, maximize recall. Example, disease detection, fraud detection, safety alerts. In that cases, we want to minimize false negative. Okay, and to minimize false positive, like spam filtering, loan approval. We don't want to give loan to any person who is not able to give back the amount. So in that case, we try to minimize false positive. So we maximize precision. Okay, then come F score family, balance between precision and recall. So this is 2 into precision into recall upon precision plus recall. Okay, so it ranges 0 to 1 and higher is better. Okay, and F1 score, uh, if false positive is 0 and false negative is 0, and then F1 score will be 1. And beta score give different weights to recall and precision. If beta is greater than 1, recall gets more weight. If beta is less than 1, precision gets more weight. Okay, so this is the formula for F beta score. 1 plus beta square into precision into recall upon beta square into precision plus recall. So This is the different same thing. Now come the specificity and false positive rate. I told you specificity is how well the classifier identify actual negative result. So it is like specificity is negative predictions to the actual negative. So that is specificity. And false positive rate is like negative values that are mistakenly considered as positive upon total actual negative. Then come the most like it is most important topic in this. I should say it's not most important, but it is generally most asked in the interview. That is ROC AUC type. ROC AUC is a performance measurement for classification models at various threshold settings. Okay, so it is for here on x-axis we have for positive, and here we have true positive rate. Okay, this is the random model. This line. Okay, and then we the more it this point is close to this point, and more better our model is. Okay, that is the so area under the curve. So if you see, we have a UC of 0.90, it is more close. And if we have a UC of 0.80, it is distant from this point. Okay. And if we have a UC of 5, it is from the middle. Curve close to top left. Models separates classes well. And it is moderate and it is random. Now the classification report. Classification report contains precision, recall, F1 score, and support. So, support means number of occurrences of each class in white. So, it show that what is the number of occurrence. Okay, so this is the this is the answer for this model evaluation techniques. In our next video, we will discuss questions regarding NLP, natural language processing, recurrent neural network, LSTM, and language modeling. Okay, so thank you for now.